Video Lecture 6.5, Transform Faults, also known as Transform Boundaries. Key to understanding a transform boundary, it's not divergence or separation like we looked at when we looked at Iceland. It's not what we're going to look at next when we look at convergent plates where we have arrows that are coming into each other. Instead, it's more like a highway in which you're driving on one side of the road, the person going the other direction's on the other side of the road, and so you're going in opposite directions. So key to understanding a transform boundary, it's not collision and it's not separation. Now for some key terms and definitions of transform faults. First off, like I mentioned, they slide right by each other. Further, these aren't going to be big landform changers. These aren't going to be ones that create huge rift valleys like we saw with divergent plates, and they're not going to be creating mountains and island chains like we'll talk about shortly with converging plates. Not to say these don't cause death and destruction, though. These are key to understanding earthquakes. There's no doubt about it. However, they're minimal landform changers. They're not going to create massive landform features. Further, there's two types we're going to look at, a strike-slip fault and a normal fault. A strike-slip indicates horizontal fault movement. And I'll show this with a web link here in a minute. The San Andreas Fault, which we'll look at in a future discussion. San Andreas Fault in California is very famous for understanding why they often have earthquakes and subsequently landslides there in California. It's an example of a strike-slip fault. Further, another type is a normal fault, and that's where we have vertical fault movement. Of course, horizontal, vertical, what do I mean? Great animations here that I'll show right now. So click on the two links here on the screen, and it'll take you to one that's an example of a normal fault. In fact, it's what they call a dip slip, and the other one is a strike slip fault. To help visualize transform boundaries, we'll use once again our very complex illustrations, and so we're going to see a little bit of landform change along this fault boundary, but we're not going to see the massive landform features created in the other two types of plate boundaries. Here in our illustration, the plates are now going to start sliding by each other, illustrating a transform fault, and more specifically, a strike-slip fault, as the pink plate slowly slides by the stationary yellow plate. Here's our transform fault boundary, the San Andreas Fault. We can see on one side of the San Andreas Fault is Los Angeles, and on the other side is San Francisco. So one of the things you'll note is the arrows indicate the direction that the plates are moving. This is kind of hard to fathom, but over time, Los Angeles will actually move, this will be once again way after we're gone, move further north than San Francisco, and so eventually Los Angeles will be north of San Francisco as this plate continues to move to the north, whereas the other one, the North American plate, relatively moves to the south. There in the Caribbean is the country of Haiti, which has had a series of natural disasters that has definitely wreaked its havoc here. One of the natural disasters has been a recent earthquake that has occurred right here along a transform fault boundary that goes right through the middle of the country. This is even more problematic because most of the people in Haiti live right there along that fault boundary. And so one thing to note is these do cause death and destruction. Although they're not big landform changers, they're not big landform creators, they definitely, with the form of earthquakes, can do their damage.